Christians, we're ready to go.
Okay, great.
Excellent. Where are you going to stand? Right there?
Yeah, here.
Excellent. Great.
Okay, so I'm doing a presentation on the actual paper of possible artifacts of data biases in the recent global surface warming hiatus. Now, the hiatus, in a little more detail, occurred from the period of 1998 to 2012, and as Thea said, it was a slowdown in the warming trend that was seen over the past 60 years. The actual trend they saw, according to the data, was actually a third to a half of that previously known trend. So it was significantly lower than anything they had seen before. And it inspired a lot of explanations to try to figure out why. And they attempted to explain it by changes in radiative forcing and atmospheric circulation and others. But because of that, not a lot of attention was given to articles that actually try to explain if it happened. They just try to explain why it happened, which is why what this article aimed to do is explain that it did not actually happen, and it was only a factor of biases that existed in the data they used. So to collect the data for their trends, they attempted to create 3 different trends, one for global, one for the ocean trend, and one for land. Now for global, their main data came from surface air temperature observations, from weather observing stations over land, so there are thousands of those across all the continents. For the ocean, there were sea surface temperature observations taken by ships and buoys, which I'll explain in further detail. And for land, there was land surface air temperature observations taken from the ISTI data bank, as Thea explained. Now, they were found to be biases in the data, so they tried to correct these biases, and they did so in a few ways. By 1, increasing sea surface temperature data from buoys, 2, increasing the ship data from the engine intake thermometers, which I'll explain in a little more detail, and increase land station data, which gave them a better land and global estimate. Now, for buoys and ships, the way the data was collected was different, but both gave them sea surface temperature observations for the ocean. Now, buoys were found to be generally more precise than ships. They float around and they're generally anchored and moored, and they take automated sampling, so that eliminates any human error. So because of this, their values tend to be more precise or close together than the ship values. Now, the increase in the amount of buoys in the water-taking measurements has increased the data coverage, the global coverage of the oceans, to 15% of the global oceans, which is a significant increase over previous times. Now, ships generally use 2 methods to gain their data for global warming trends, or sea surface temperature trends. They use the bucket method and the engine intake thermometer method. Now, the bucket method is just hauling up a bucket of water and taking the temperature measurements from it, and this is a very, very old method. They generally don't use it as much anymore. The intake thermometer method is a thermometer actually in the intake of in the engine cooling intake that measures the temperature of the water as it gets sucked in. Now, most ships moved from the bucket method to the intake thermometer method in the 40s because it was found to be more accurate. It was found to be more accurate because the bucket method generally allowed for some cooling before measurements were taken, so it was more time dependent, whereas the intake thermometer method generally allowed for the taking of temperatures actually physically in the ocean. They didn't have to take it out of the ocean to measure. Now, some new data showed that some ships still use the bucket method today. Now, because it's less accurate, this led to some time-dependent biases in the data. to the point where they did not believe they could trust the ship data as much anymore. So because of that, they had to create corrections in order to rely more on the buoy data rather than the ship data. Now to fix these, because of these inaccuracies with the ship data, the buoys were found to be systematically less warm than the ships. The buoys gave smaller trends than the ships, and this resulted in the time-dependent biases. So to make the data more equivalent between buoys and ships, they calculated the average difference between parallel or similar time and location measurements taken from ships and buoys, and found that it was negative 0.12 degrees Celsius, which is small but still enough to create a difference. Now this difference was added to the buoy data, and that allowed the buoys and ships to have more equivalent data, less outliers. They matched each other better. Now because buoys generally tended to be more precise, their values tend to be closer together than the ship data, when it was added to the ERSST that Thea talked about, it was given a greater weight percentage than the ship data. So more of the data relies on the buoy measurements than the ship measurements. Now this correction was extended to the present from the beginning of from the very beginning actually of the measurements taken from the bucket method from around the 40s to the present day time. The last data they have for that is about 2014, and it accounted for a 0.03 degrees Celsius per decade difference between the new and the old data in the 21st century. So from 2000 to 2014, which is actually about half of the total difference that they found with all their corrections. Now for land, as I said before, they used the ISTI data bank, and that is combined with the GHCN data bank, including more than 40 historical sources that allowed them to get more general coverage of land. Now the data they found was corrected to address changes in sample location and instruments, and it was corrected by having a global averaged anomalies in a very complicated way of doing it. It involves mostly math, but the most important part is just that corrections allowed them to improve their spatial coverage over land, specifically over the Arctic, in which the coverage was generally lacking. Okay, so global. The corrections for global, the data for the global trends was generally shown to be underestimated, specifically due to an incomplete land area coverage over the Arctic. And that was found in the old and the new data. Even with the new spatial coverage over the Arctic, the new data was still found to potentially underestimate the actual amount of warming. So in order to do this, in order to try to help correct this even more, they tried to consider the impact of higher warming rates in higher latitudes by using large area interpolation over the poles to try to quantify the actual warming over them. Now, Figure 1. Figure 1 shows degrees Celsius per decade trend for the global, ocean, and land over 5 different time periods. The first two of which were the ones that were reported in the IPCC report, which was the base period of the last 60 years and the hiatus period of 1998 to 2012. Now with their new data, they also looked at trends for 1950 to 1999, 2000 to 2014, and 1998 to 2014. So D and E show only 2 to 4 year differences between 1998 and 2012 because they wanted to see if changing the year by only a little bit would actually change the data or if the trend would stay the same. Now, the circles represent the old data, what was reported before their corrections. So these two were actually in the IPCC report, those values. The squares represent the new data, their corrected data, and the triangles, which only show up in the C, D, and E of the global trend, were specifically found using the large area interpolation. Now, the vertical lines represent the 90% confidence interval for each data set, each data point, and the dashes on the top and bottom represent the extra error that they found later. Now, for the actual data, the new sea surface temperature analysis for the oceans found that, or increased the warming trend for their new data to 0.075 degrees Celsius per decade, which is here. I guess I'll use it. Which is here, versus the old data, which showed a 0.014 degrees Celsius per decade. So it's a more than double increase in the previous data in the trend for what was thought of as the hiatus period. Additionally, the new land surface air temperature analysis for land showed an increase in trend, although albeit only slightly, it was still showed an increase only by 0.117 degrees Celsius is the new data, and the old data showed 0.112 degrees Celsius per decade. So only a very small change, but still an increase nonetheless. Now these analyses all combined together create the global trend, which showed a greater than double increase in the general trend from 0.039 degrees Celsius here to 0.086 here. So another greater than double trend increase in warming trends for what was used to be thought of as the hiatus period. So the trends for the hiatus period and for the base period became significantly closer together with the newly corrected data. Now the period of 1998 to 2014, which is shown on E, showed a 0.02 degrees Celsius higher with the new data than the hiatus, and the period of 2000-2014, only the 21st century, showed a 0.03 degrees Celsius per decade difference, which told them that the trends found differed depending on the start and end date, which made them think more that the hiatus may have been due to, what was thought of as the hiatus may have been due to some different factors, because if they expanded the trends by only 2 years, the actual trends they found, or they expanded the start and end date by only 2 years, the trends they found were much closer to what was found in the base period. Now, the new data lessened the difference between the trends for the hiatus period and for the base period from 0.078 degrees Celsius per decade between these two values and 0.043 between these two values, so a significantly lesser difference between the two. Now, Figure 2. Figure 2 showed of the full record time chart of temperature anomaly from 1880 to 2014 for the global analysis. The first A shows the new corrections that they have versus the old ones, and B shows new corrections versus none at all. Now, A showed a general consistency between the new and the old corrections for the temperature anomaly from 1880 to 2014, which the authors suggested supported their assumption that the new corrections only affected the more recent times or where the hiatus existed, which is around here. Now the new corrections and the old corrections had significantly different data, which the authors suggest that the old data actually had a greater warming trend since it increases more. So the new data led to a more consistent temperature anomaly over the entire over the entire record of data. Lastly, Figure 3 shows a temperature trend of degrees Celsius per decade across all the latitudes for global ocean land, similar to Figure 1. and it shows it for 2 time periods. The dashed line represents 1950 to 1999, so about 50 years, and the solid lines represent only the 21st century. Now for all 3 trends, all 3 graphs, the dashed line was relatively linear. It showed it didn't have any significantly large increases or decreases in the data. However, in the 21st century, specifically for the ocean and land, mostly, the Arctic latitudes showed a significant warming trend in both of them, and somewhat for global too, but especially once you get up into higher latitudes for the ocean. Specifically for the ocean, actually, when you're comparing the 21st century to the previous century, the increase was the greatest. Now, the northern middle lats actually in land, only about right here, actually showed a decline in warming at that specific latitude with the new data. Now, the middle latitudes for all the data points showed general consistency with the data from the previous century, so not too much of a difference. So their general conclusions for the paper were that the data did not support the
Back up one, you skipped it.
Yep.
Right.
but that the data did not support the hiatus because the temperature. Because generally the trend from 1950 to 1999, the 50-year trend of 0.113 degrees Celsius per decade increase, was too similar to the newly calculated trend of 2000 to 2014 of 0.116. So the data was too close together with their new corrections to actually support the hypothesis of a hiatus. However, they do admit that a continual lack of spatial coverage over the Arctic may still hinder the accuracy of the data, although I believe they suggest that it still may underestimate the data, so it might be even more today than we estimated. Now, lastly, they say that the odd trends that they saw starting in 1998 may have been due to the fact that that year was a very strong El Nino year, so it may have skewed their data. Citation. That's how it works.
Ooh, wow. Thanks, Christian.